Kelsey, please. Actually, come on in. Let's do some math.
Okay guys, so today we're going to be doing question 52 from the textbook, and this is chapter 3.5, so it's about the chain rule, but this question also includes the product rule, so get ready. Basically the question says, if g is a twice differentiable function and f of x equals x g of x squared, find f double prime in terms of g, g prime, and g double prime. So I'll be inserting the little question. So essentially what this question is asking us is to find f double prime. Okay, so as we've learned from chapter 3.5, sometimes the product rule and chain rule can combine, or chain rule and any other rule. So also we know that to find f of x double prime, first we need to find f prime of x, right? So to do that, I use the product rule and the chain rule, and we know that the chain rule is used when there are two functions, so I use that on gx squared. And since there are two distinct functions in this f of x that are being multiplied together, we know that we can use the product rule. So our distinct functions are defined by u and v. So u is x and v is gx squared. And then I differentiated both of those. So x becomes 1, as we know from the power rule, and v prime becomes g prime of x squared because we don't know what that function actually is, and that's multiplied by 2x because we differentiate the equation or the function that's within g of x. So now all we have to do is plug that into the equation, and we use the product rule for that, and we know that the product rule states that f prime of x equals v times u prime plus v prime times u. So we just plug all of those in. We substitute the functions that we found for the variables of u and v, and our final answer of f prime of x is gx squared plus 2x squared times g prime of x squared. So that is f prime of x in terms of g and g prime. So now the next step is to find f double prime of x, which is the whole point of this question. And again, we use the chain rule and product rule to find both of these. So we go back to the equation that we had before, the f prime of x, and we use those two functions to find f double prime of x. Now first, all we have to do is differentiate the first function, which is gx squared that we found in the last problem, in the last step, sorry. And the differentiation of that is g prime x squared times 2x, and we used the chain rule for that. And now we add that to the derivative of the second function that we have, because g of x squared and 2x squared g prime of x squared are being added together in f of x. So to find this differentiation, we use the product rule. So the product rule is the same as how we used it in the first step. It's just defining u and v and then plugging it into the function. So as we have to find the derivative of 2x squared times g prime of x squared, I just like to call that h of x. And we plug it into the equation and we have our final answer. So now we just go back to our f double prime of x, and we plug in the derivative that we just found, the derivative of h of x, as I showed, and we just add those together and simplify it to get our final answer of f double prime of x, which is 6x g prime of x squared plus 4x cubed g double prime of x squared. And now we can see that they're being defined as g prime and g double prime, which is what they ask in the question. So, hope you had a super fun time. That's how you do the question, and have a great day.